Hey guys, I'm the tech guy. Today we are testing Sarvam AI, which is India's first LLM against one of the most interesting reasoning benchmarks out there, which is the Hexagon Test. So, what does the Hexagon Test do is it asks like any of the LLM models that we have to write a Python script that stimulates a ball bouncing inside a rotating hexagon. But like under the hood, the task is extremely demanding. It's just not simple as it sounds. It requires geometry, rotational transformation, collision detection, vector reflection math, and stable like real-time simulation logic. Basically, it's just not a coding task. It's like a reasoning stress test for the LLMs. To solve it correctly, the model needs to calculate wall normals, handle coordinate transforms for rotation, reflect velocity vectors accurately, and maintain stability as angular velocity increases. If any of these steps are weak, the simulation breaks. The ball may pass through the walls and bounce incorrectly or behave unpredictably at corners. So let's see the video of how Sarvam AI does against this hexagon test. So let me start the video of the hexagon test for Sarvam AI. So as you can see, Sarvam generates structurally correct Python code. It sets up the hexagon, defines the ball, implements collision logic. At a basic level, the simulation runs. That's a good sign. It shows the model understands the overall structure of the task. However, when rotation is introduced, like as you can see in the video, limitations begins to show. The handling of rotating framings is not consistently accurate. Collision normals are sometimes approximated rather than calculated precisely. At higher angular speeds, instability becomes visible. Edge cases, especially corner impacts, are not always handled correctly. Let me like replay the video for you to understand like what I just went through here. Like the initial setup is right, but it's unable to like handle once the collisions and the bouncing is introduced. So what does this mean? Now let's in short, Sarvam passes the basic implementation stage but struggles with the advanced mathematical precision. Now let's compare this to the large LLMs we have right now, which is like Cloud or ChatGPT or Gemini, and see like how it compares. Like top tier models tend to implement more precise vector mathematics. They handle all the coordinate transformation more rigorously and produce cleaner modular codel. Their collision detection logical is usually more stable under stress conditions like high rotation speeds or sharp angle impacts. They are able to handle better, and the ball doesn't bounce out of the hexagon. In benchmark style comparison terms, Sarvam handle structure and basic logic well, but leading LLMs, what they do is they handle advanced math, physics, consistency, and they have the edge case stability better. The difference here, what we see from like the top tier LLMs and Sarvam, is that the training depth that they have gone through, including like things like advanced mathematics, physics, simulations, and complex coding tasks. Models heavily trained on scientific and simulation heavy based datasets naturally perform better in tasks like this. So that's where the lack of consistency that we see on the test that we just noticed in Sarvam AM comes from. That said, Sarvam is reportedly built from scratch, which makes this result interesting. For a newer model, producing a mostly functional simulation is a solid baseline. With stronger exposure to advanced math and physics data as the learning continues for the LLM, the performance could improve significantly in future iterations. The hexagon test isn't just bouncing balls inside polygons, it's a compact benchmark that reveals how deeply a model understands spatial reasoning, applied mathematics, and multiple step logical consistency. Right now, Sarvam shows promise, but leading LLMs still maintain an edge in complex reasoning benchmarks like this. And that's because they have been trained for a longer period of time, and Sarvam is just built out of scratch, and this is just the beginning. So that's why these tests like this matter, and we'll do a test again after a couple of months when Sarvam is more learned, and we'll see how it performs. Till then, bye bye, and do subscribe to the channel if for more interesting tech related videos.